Hi everybody, this is Morgan here with Positive Approach to Math. I am going to break down the U-try for lesson 1, what is a linear function, in our linear equations topic. So if you need some extra guidance with these 6 problems, please watch this video to hopefully help straighten things out for you. So just a little recap, when we're talking about whether or not an equation is linear, we're looking for certain things. So we don't have to graph every equation to determine whether or not it is linear. We can just look at the equation and look for certain characteristics or things that we don't want to see. So just a reminder, things that are linear will have at most 2 variables. So you will not see any more than 2 variables. So at most, I'm going to say 2 variables. The exponents on those variables will be a 1. I like to say nothing crazy happening to those variables. It's a plain old x, a plain old y. They are not in the denominator. And last but not least, you are dealing with all real number coefficients and constants. So I like to say, okay, a plain old x, a plain old y, meaning there's no crazy exponents on them. They're not under a square root. They're not in an absolute value. They aren't in the denominator. You just see a plain old x. It could have a fraction in front of it as its coefficient, but what is important is that that variable, that x or y, is not in the denominator of the fraction. So let's look through these. The first one, we have y plus 2 equals 4x. So if I look at that, I see a y and I see a 4x. Nothing crazy happening to that y, nothing crazy happening to that x. The 2, the 4, and the coefficient of 1 in front of that y are all real numbers, so this is linear. I also like to remind you to make sure you are simplifying your equation first. So if you do have like terms, you want to combine them before you make your conclusion. Number 2, we have a y cubed. Right off the bat, I see an exponent that is not a 1. Equals 2x squared minus 3. So we have 2 variables, which is great, but both of them have exponents that aren't 1. So therefore, this would be non-linear. Okay. Number 3, we have 1/2 plain old x plus 3/4 plain old y equals 6. Nothing fancy happening to that x. It's being multiplied by a fraction, but that x is not in the denominator. Plus 3/4 y, it's being multiplied by that fraction, but again, not in that denominator. So this would be linear. Number 4, we have y looking good equals the square root, and under that square root is an x. So that is not good. We cannot have a square root with a variable under it, right? If I had this, let me just show you. That would be okay, right? But because that square root has the x under it, it is non-linear. Remember, a square root is really an exponent of 1/2. So that is really saying x plus 5 all to the 1/2 power. Okay, I'm going to scroll down for number 5. 4 over y equals 2, so it's okay to have one variable. However, that variable is in the denominator of that fraction, so that is non-linear. Something's crazy happening there. And last but not least, we have 7y equals 6y plus 3x. So here's where they're trying to trick you. They're showing you y, y, and x. But notice the 7y and 6y are like terms, so we can combine them. I can either subtract the 6y and bring it over to the 7y, or I can subtract the 7y and bring it over to the 6y. I'm going to bring the 6y over by minusing it on both sides. That's going to leave me with 1y equals 3x. So we have a plain old y and a plain old x. nothing crazy happening to them. You might say, oh, well, there's not a constant. Like look at number 3, for example. You have a plain old number that doesn't have a letter, but that's okay because really what you have is like a +0. That is your constant. So this would be linear. So hopefully that helped you differentiate between equations that are linear and nonlinear. Just a reminder, linear equations mean that if you go to graph them, they're going to form nice straight lines. We're going to dive deeper into our linear equations and all that it entails in this topic, so keep watching for more great math videos.